Hello. In this video we're going to look at the measure of central angles and inscribed angles in a circle. Okay, here I have circle P drawn on dot paper that represents a circular geoboard. It's circle P because that's the center. P is the center of the circle. And going around the circle there are 12 dots, which if we wanted to find the distance between the dots in terms of angles, since there's 12, then going around the circle completely is 360 degrees. There's 12. So then between each of any two dots, it's 360 divided by 12. It's going to represent 30 degrees. So from here to here is 30 degrees. And between any two dots represents 30 degrees. Now the measure of the central angle is the same as the arc that it cuts off, or the intercepted arc. So if I draw an angle like this, then this angle, this is 30 degrees, this is 30 degrees, so this angle is 60 degrees, and the arc is 60 degrees. Anywhere, as long as it goes through the center of the circle, and it cuts off an arc, it's the same as the measure. The angle is the same as the measure of the arc that it intercepts or cuts off. Now, let's suppose that I have an angle that just touches the outside of the circle. Let's say like this angle all the way. I'm going to go all the way across. And when it goes all the way across, that's the diameter. So the diameter of the circle, and I'm going to go over here. And now it's intercepting the same arc. But you can see that this angle right here is going to be smaller than 60 degrees. You can see that. But how big is it? Well, we know that this is a radius, and this is a radius, and this is a radius. So since these are radii, and then this makes a straight line, it's the diameter. Since this is 60 degrees, then this angle is going to be a linear pair with that. So then this angle has to be 180 minus 60 degrees. So this angle right here at P, which I'll erase, in the way, is going to be 120 degrees. So now we see that we have an isosceles triangle. So that means these two angles are congruent. So since those two angles are congruent, we can take 180 degrees and subtract, since the sum of the measures of the angles of triangles 180 degrees, subtract 120, and we get 60. And that's the measure of both angles added together. So we divide it by 2, and this angle is 30. And this angle is 30. So that means when we have an angle that's just inscribed in a triangle, just right on the edge of the triangle, then it's going to equal 1/2 of the arc that it cuts off. Now there's several different ways that I could have drawn the intercepted angle, but it still comes out to be the same, that it's always going to be 1/2 the measure of the intercepted arc. Now, since the inscribed angle is half of the intercepted arc, there's a really important consequence of that is heavily tested on standardized test, and that's right here. See, I draw the diameter. Well, the diameter divides the circle in half, so the measure of this arc is 180 degrees, the measure of this arc is 180 degrees, and most of you realize that the measure of the line is 180 degrees. But if I were to draw in an angle right here, then the question is, how big is this angle right there when I draw in a triangle? Well, it's half of the intercepted arc. From here to here, here's the arc that it intercepts or cuts off. This is 180 degrees, so then this angle has to be 90. This is 180. We take half of that. That angle's 90 degrees. No matter where I draw it, it's going to be 90 degrees. I can draw it over here. And so this, like I said, it's tested heavily, because once we know this, we also know that those two are radii. If they give you the angle over here, and let's say they tell you that this angle is 30 degrees, well, if we know that this angle is 30 degrees, then we can use the 30, 60, 90 and come up with the length of this side, which would be half of this. So this would be 1, which is the same as the radius, and then we can come up with that side. They could put the angle right here in the center, and they can come up, draw it in as a 45, 45, 90. But there's a lot of questions that come up on standardized tests based on the idea that any triangle, if it's inscribed in a semicircle, it's going to be a right angle. Okay, so that's really important, and I wanted you to make sure that you realize that. Okay, I hope you found this interesting. Thank you.